Bismillahirrahmanirrahim. Boole's inequality. For any n events a1, a2 up to an, probability of I runs from 1 to n of ai, this must be less than or equal to I runs from 1 to n probability of ai. This is Boole's inequality. Proof. To prove this Boole's inequality, we use mathematical induction. We know that mathematical induction first step is we prove it for n equal to 2, that is, we consider only two events a1 and a2, and then second step we prove, we suppose it is true, we suppose that it is true for n equal to k, and last step we show that the result is also true for n equal to k plus 1. If we complete these three steps, the net result will be, the theorem will be true for all n. So the theorem will be true for all n. So consider the left hand side of this inequality, that is for n equal to 2, that is probability of union I runs from 1 to 2 of ai, this will be equal to probability of a1 union a2. So this will be equal to probability of a1 plus probability of a2 minus probability of a1 intersection a2, that is by the addition law of probability per two not mutually exclusive events, implies that probability of union I runs from 1 to 2 of ai, this will be less than or equal to probability of a1 plus probability of a2. When we this side is equal to this side only if we subtract this term. If we subtract this term from the right hand side, so it will be equal to the left hand side. And if we don't subtract this probability of a1 intersection a2, so these two values will be greater than this probability. These two values will be greater than this probability. In other words, this side will be smaller than, this side will be smaller than this one. When we drop this term, it means that when we drop this term, we don't subtract this term. Here in this step, we have dropped this term. So what does it mean? This side will be larger than this side. Why? Because these two sides are equal, subject to the condition that when you subtract this quantity. So if we don't subtract, it means that this side will be greater than this side, means that this will be smaller than this, and this is equal to probability I runs from 1 to 2 of ai, means that this thing will be smaller than these two. So we have written, implies that probability of I runs from 2 of ai, this will be smaller than, less than or equal to probability of a1 plus probability of a2. Implies that probability union I runs from 1 to 2 of ai, this is less than or equal to, इसको आप sum introduce करें, I runs from 1 to 2 of probability of ai. So the result true for n equal to 2. Let it is true for n equal to k, implies that probability of union I runs from 1 to, हम अब क्या करते हैं, इनकी जगह k पुट करते हैं, अब ai, this will be less than or equal to I runs from 1 to k probability of ai. Okay, let it is true for n equal to k. So this theorem is hold for n equal to k. Let me suppose it that it is true for n equal to k. Now we have to show that it is true for n equal to k plus 1. Consider n equal to k plus 1. Therefore here आप क्या करें, लेफ्ट हैंड साइड में आप I runs from 1 to इनकी जगह k plus 1 पुट करें आप ai, so this will be equal to, you can write this union I runs from 1 to k of ai union ak plus 1. You can write in this manner. These two events are not mutually exclusive, so this can be further split by addition of probability for two not mutually exclusive event. This will be equal to probability of union I runs from 1 to k of ai plus probability of ak plus 1 minus probability of union I runs from 1 to k of ai intersection ak plus 1 implies that probability of union I runs from 1 to k plus 1 of ai. This side will be smaller than if we drop this term, because when from the addition of these two terms, when you subtract this term, then it equals this term. So when you drop this term, what does it mean? The sum of these two terms will be greater than this term. In other words, you can say this thing is smaller than probability of union, the sum of these two terms, that is I runs from 1 to k of ai plus probability of ak plus 1. Now let's say this is equation number 1. So using this equation, this side is smaller than this side. What does it mean? This quantity is larger than this quantity. So replacing this quantity, which is smaller quantity, by this larger quantity, replacing this quantity by this quantity, and this quantity is larger than this quantity. When you add a larger quantity here, what does it mean? This side will become more larger, so this side will be smaller. So by equation 1, by inequality 1, probability of union I runs from 1 to k plus 1 of ai will be equal to, is less than or equal to, हम इसकी जगह क्या करते हैं, इस दिस लार्जर टर्म को हम रिप्लेस करते हैं, I runs from 1 to k probability of ai, और प्लस जो है हम ये टर्म लिखते हैं ak plus 1. So this sum can be further extended, that is I runs from 1 to k plus 1 of ai implies that probability of union I runs from 1 to k plus 1 of ai will be less than or equal to. Now extend this sum from I runs from 1 to k plus 1 and simply write here probability of ai. When you expand this for k and k plus ak plus 1, so this you will get these two terms. So the result followed for n equal to k plus 1. So it is true for all n. Show that probability of a is less than or equal to probability of b if a is a subset of b. अगर a subset है b का, अगर a एक subset है b का, तो probability of a must be less than or equal to probability of b. Proof. Consider two events a and b in a Venn diagram. That is, we have two events a and b. This is event b and this is event a. Because a is a subset of b, a is a proper subset of b, so a is totally inside b, and this is the sample space rho. So b can be written as, event b can be written as the union of two mutually exclusive events. B can be written as the union of two mutually exclusive events, that is a union b intersection a complement. ठीक है, b intersection a complement. b intersection a complement is this region. b intersection a complement is this region. So B intersection A complement is this dash region. So how we will represent this B intersection A complement region? So if you have, again we draw this event. So this is A and this is B because A is a subset of B. अब हम A complement को मालूम करते हैं. What is A complement region? A complement region is this region. A complement region is this region. ठीक है? This is A complement region. Excluding region of A. A के अलावा जितना भी रीजन है इसको हम A complement रीजन कहते हैं. अगर इस A complement रीजन को ये जितना भी हमने ये डैश ये शेडेड रीजन जितना भी हमने बनाया ये क्या है? ये A complement रीजन है. कौन सा रीजन है? A complement. अगर और B का जो मुश्तरक रीजन है A complement का, इस A complement का B के साथ कौन सा रीजन मुश्तरक है? ये वाला रीजन मुश्तरक है. तो ये रीजन हमारे साथ ये कौन सा रीजन है? ये A complement और B का मुश्तरक रीजन है. तो हम इस तरह लिख सकेंगे A complement मुश्तरक B means intersection B. So this is the region. So we have specified here this region is A complement intersection B. A complement intersection B region. So this A and A intersection B complement region, A complement intersection B. So this A and A complement intersection B region are mutually exclusive. This A and A complement intersection B region are mutually exclusive. So taking probability of both sides, probability of B will be equal to probability of A union B intersection A complement. But this event and this are mutually exclusive, so straight away this can be written as by addition law of probability for mutually exclusive event is equal to probability of A plus probability of B intersection A complement. Implies that probability of B is equal to the sum of two probabilities, probability of A plus an additional probability B intersection A complement. Definitely if we drop this term, so this term will be greater than this term. Probability of B will be greater than probability of A, or in other words you can say probability of A will be smaller than probability of B. Hence proved.